All right, so we're going to get started. My name is Damien, and I'm one of the organizers for this meetup. And this is the meetup for August. So nice to see all of you here. So today's topic is going to be on exploring declarative policy management with Kyverno. So basically, this presentation is not going to be too long. This is the outline that we're going to follow. So I'll first of all give you an overview of Kubernetes policies, why we need this service called Kyverno. And then I will give you an overview of what the service does, and then give you some introduction, and pretty much give you a demo, and then we're going to round up. So it may not be a very long presentation. It just depends on questions and every other thing that that happens during the presentation. All right, so let's get started. So what is policy management? First of all, before we really understand why policy management is important, we need to understand how Kubernetes works. Okay, so Kubernetes uses a declarative format. What that means is that before you can create any object in Kubernetes, you have to first of all create a YAML file. It could also be a JSON file, but YAML is recommended. So you will put your instructions in a YAML file, and then you will give that YAML file to the Kubernetes API, and then the Kubernetes API will create the resource, which means you usually have to present your instruction to Kubernetes in what we call the desired state. This is what you want your infrastructure to look like. The next thing is for Kubernetes to actually create this object, this desired state that you've given onto it. And once Kubernetes has created the object, normally it will also monitor the object to make sure that any differences, any disparities between the current state of the object and the desired state which you presented to it are reconciled. So Kubernetes has controller objects, and these objects are constantly or continuously monitoring your objects to ensure that the desire you put in your file is actually what you have running in the cluster at the moment. Okay. So we need to understand that concept that we're going to be working with a lot of files. Okay, so the next thing that comes then is, how do you know that the objects that you are creating in your files are actually valid? When I say valid, it means maybe your organization has some policies, and those policies are required to be enforced in your environment. So if someone have some configurations which are not desired, which are not allowed within your organization, how do you actually stop those resources from being created in your environment? Okay, so this is where this concept comes in. Excuse me. Excuse me. Okay, so let's continue. So basically, the point I'm trying to make is this. You have a file in which you put some instructions. Eventually, the instructions you put in this file are going to be created into your environment, into your Kubernetes cluster. Whether the information put in there is not allowed in your organization or not, they will get created because Kubernetes on its own wouldn't know. So it is the role of the policies to ensure that the configuration files conform to certain policies. So basically, when we talk about policy management, we're in essence talking about how you manage your configuration files, how you ensure that the YAML files you're creating are conforming to the policies that you specify within your own organization. Okay, so in essence, that is what policy management is all about. Now, left at that alone, maybe it would have even been easier. But the problem is when you deploy your clusters these days, your clusters are going to be sometimes they are multi-clusters. Okay, so you have a lot of clusters. We also talk about the concept of federations, where you have a cluster spanning different locations. And so in this case, how do you ensure that your policy files are actually being enforced across your entire cluster? Okay, so like I said, within this single Kubernetes cluster, maybe it's even easier to monitor your configuration files, but across different clusters, it becomes even more complicated. Okay, and usually the way Kubernetes clusters are deployed these days, or at least the way enterprise organizations using Kubernetes, the way they operate mostly these days is that they have a team which is responsible for managing the Kubernetes cluster. That team could be also responsible for deploying and managing all the resources required by your cluster. You know, things like monitoring and logging and all the other infrastructures which Kubernetes requires. And so again, how do we ensure that the files you are creating are all conforming to a policy that you require to be applied across everything within that centralized system that you're trying to manage? So Kubernetes gives you some local API file, API objects that you can use to create those policies. However, one thing is being able to configure those policies correctly, and another thing is being able to apply them across these different clusters that you have. And so based on all these challenges that organizations are experiencing, came the concept of policy management. And Kyverno that we're going to be talking about today is actually not the first in this area. There's something called the OPA, Open Policy Agent. And Open Policy Agent is a specification on how to manage policies across a distributed environment. Okay. Then Kubernetes had an implementation called the Gatekeeper. So which means the Gatekeeper of Open Policy Agent was implemented just specifically for Kubernetes environment. What this means is that this OPA is not specific to Kubernetes, though it does have an implementation configured for Kubernetes, which is what we call the gateway. Okay, but we can say that Gatekeeper is not Kubernetes native. It doesn't speak the language of Kubernetes, though you can still make it to work, and it has its own programming language. And so Kyverno was the first to enter into this scope of policy management, which is Kubernetes native, which means it's built specifically for Kubernetes. And it's very similar to how Kubernetes does things. For example, to create your policies, as we're going to see very soon when I do the demo, it is just like you creating an ordinary YAML file that you normally create for Kubernetes. And so this is the policy that I would say makes things easier if you are trying to configure a policy across your own organization. And so I would say this is what a lot of people are using at the moment. Okay, so hopefully that helps you to understand why the policy management is important. Every organization will need this capability, either sooner or later. It just depends on what stage you are in managing your Kubernetes environment. Okay, so that is what we're going to explore today. We'll look at how Kyverno does things, and then I'll show you some demo, some examples of how to apply these policies across your cluster. And then pretty much we're going to round up after that, depending on how many questions we have to answer. And if you have questions anytime, feel free to send it to the chat box, and I'll do my best to take a look at it, and then we can talk about them later on. Okay. So here on the slide, I talk about Kyverno policy management. We understand that managing Kubernetes configuration can be complex because we're just dealing with all these YAML files. And in these YAML files, this is where you're creating your desire. Again, across different environments, that can be quite complex. Okay, so policy provide a way to define standards and best practices. Okay, standards and best practices. Some of these standards and best practices are actually provided by the Kubernetes community, and I will show you some of them. But at the same time, most organizations also have their own policies, which you may want to conform to. Okay, so let me show you some of the best practices in doing your configurations here from the Kubernetes website. So if you go to this link, we have here the configuration best practices. And if you've been working with Kubernetes for some time, you may be familiar with some of this, or you may not even be familiar with them. For example, we have here general configuration tips. It says when defining configurations, specify the latest stable version of the API. Okay, that makes sense because a lot of time I've had problems where maybe I've upgraded my cluster and then the API, the YAML files I'm using, the versions of the YAML files I'm using is no longer current, and so those objects could not get created. So if you are always ensuring that you are using the most stable version of the API object you are dealing with, that will make life easier. For example, when you are trying to work with something like a deployment object can have different versions. Sometimes you have it as alpha, sometimes you have it as beta version. So if you know the current most stable version, it makes sense to use that. Okay, so that's one general tip there. And then we have here too, configurations files should be stored in version control before being pushed to the cluster. Okay, this is basically the concept of GitOps these days. So you put all your configuration files in something like Git, okay, so that you can easily version them and then be able to control and manage the different versions that you are creating. And here it says write your configuration files using YAML rather than JSON. Now I've seen people writing sometimes their YAML files in JSON. Nothing wrong with that. The system will still work, but here general best practice is to use YAML, which is easier for most people because it's more user friendly. It's designed more for people rather than machines. Okay, then we also have here group related objects into a single file, and this also makes a lot of sense. A lot of times I've seen where if you have a particular microservice that has different microservices, of course, sometimes people will write the files for each microservice in a separate file, but it makes sense, or it makes life easier if you put all the YAML files in a single file. In that case, you can separate each of the YAML file by just putting 3 hyphens. 3 hyphens separates one section of the object from another object. So you can look at those type of things. These are just general best practices. Okay, and I'm just showing you this to tell you that when you write your policies, you can enforce some of these things we're looking at here. And we'll see how we're going to do that in a short while. Okay. We also have all the general best practices for services objects. For labels, you always have to make sure that you give labels to your objects. But this one, I'll talk about it because it's important. This is a common example that you will come across if you are working with Kubernetes or containers for some time. All right. So here, we know that before you can create any Kubernetes, pod or deployment objects or stuff like that, any of the compute objects that you have in Kubernetes, you need the image to be downloaded from somewhere, and that image could be downloaded from Docker Hub or from any other registry that you have. And so it's often the case that sometimes you have different teams that are working on different applications, but they could be, maybe all of them require an image like MySQL. Okay, they require the image MySQL, but you know that MySQL could have different versions. Okay, so maybe you do not want to use a specific version of MySQL. However, you know that the way Docker works, or most container runtimes, the way they work is that if they want to create a container and they find the image available on the system, then they're going to use that image. Okay, they will not go and download it again. But like I'm saying, maybe we have two teams. Okay, these two teams, they have the name of the image is the same, maybe MySQL, but maybe the version of that image is different. Okay, so in that case, if team 1 goes ahead and use MySQL version 1, and that version is already available, when team 2 is trying to use MySQL, the system could reuse the existing image which is available on the system. So to stop that from happening, you can always say that you want this the container runtime to always go ahead and download the image from the registry. So which means that the image that exists already may not be used, because the system will go ahead and fetch the one that the second team is requesting. And that makes sense. It makes sense because otherwise, then they have to use the image of which is already cached. All right. So based on that, you can see here that we have different options that you can specify with your image policy. Image policy here, the first one says if not present. This is often the one I've seen, maybe pretty much like the default, which says if the image is not present, go ahead and pull it locally. If it's present, you don't have to worry about pulling it anymore. Then this one says always. This is the example I've just talked about. Always means always pull the image. Whether the cache is available or not, always pull the image. Of course, the cache will speed things up, and that is a huge advantage. But in any case, based on the scenario I've just described, we don't care whether the cache is available or not. We want to go ahead and bring it, still pull it down. Okay. Then you have the option here to say never, which means the image is assumed to exist locally. So don't even make an attempt to go ahead and download that image. So you can see this type of policies can be available. And if you wanted to ensure that your images are always going to be always pulled, but you don't put that policy in place, someone else could go ahead and create a YAML file that is required to create a pod. And if you don't have a check in place, that template will be allowed into your system. So once it's allowed, then it means that whenever they create that object, it could reuse an existing image, but that is not what you want, right? So I'm just using this as a typical example of why you will need policies. And this is just one example. There are a lot of other similar ones, which we are going to look at when we start exploring Kyverno. Okay, so you can see that these are all kind of some best practices which are specified here on the Kubernetes website. But at the same time, like I said, organizations will typically have their own policies in place to ensure that when people are trying to deploy their objects, those objects actually conform to the policies which have been laid down by the organization. Okay, so those are some of the best practices that we can follow, and I'll go back here. So like I said, doing all this within the Kubernetes native objects could be difficult or could be challenging because, for example, Kubernetes has something called a PSP, which is the pod security policy. Pod security policy applies to the pod when you create it. And you can specify those attributes in your pod when you create a pod. And some of the things you could prevent by using the PSP is, for example, to disallow a pod from using escalation, or even to use a root privilege. You can disable a pod from using a root privilege, having a root privilege, which means whenever that pod runs, you need to run as a non-privileged user. Okay, so you have those type of policies in place if you use PSP, but to just understand that even PSP is being deprecated. All right, PSP, pod security policy, is being deprecated from Kubernetes, and if that gets deprecated, they are not even thinking of replacing it with anything else. And so something like Kyverno is useful to implement those type of policies, because this is just one aspect of what Kyverno can help you do. At the same time, I said that Kubernetes has those type of policies in place. We have something called the network policies. If you have worked with Kubernetes before, you know that Kubernetes has the networking component called the CNI, the Container Networking Interface. And if you deploy your Kubernetes cluster with a CNI and you do not deploy a network policy, then you can consider that to be like the wide west, in the sense that anything goes as far as security is concerned. Any pod can talk to any pod. Any host can talk to any pod, okay? But I would say that is chaotic, because let's assume you have a 3-tier application. In the 3-tier application, where you have the web, the application, and the database, you probably doesn't want the web to talk directly to the database, all right? But like I said, the default policy with networking in Kubernetes is that any pod can talk to any pod. That is the design. So to stop that from happening, you need to make sure that you implement network policies. And it depends on the CNI that you use. CNI is the Container Network Interface. It depends on which one you use. Some have network policies, some don't. So depending on how security conscious your environment is, certain CNI plugins are just a no-no. You don't want those to happen at all, right? And so that is why something like Calico is a CNI, which is quite popular because it has a very good network policies in place. Okay, so all those type of things are there for you to implement, but they can be hard to implement locally within the Kubernetes environment, and also to scale it across different clusters. Okay, also we have something called a quota management, quota and limits. It's often the case that when administrators configure the pods, they want to make sure they set some quotas per project, okay? So that one project or one namespace doesn't consume all the resources for the cluster. So to implement those type of quota system, you need to have some policies in place. Again, managing them locally can be an issue. So all these type of examples I've just mentioned, you can use them easily within Kyverno to help you implement all those policies. All right, so we can say what is Kyverno then? It says it allows cluster administrators to validate, mutate, and generate. Those 3 words are very important. We're going to be coming across them a lot. Validate, mutate, and generate. Okay, configurations. Again, like I said, when we talk about the policy management, it's all about the configuration files that we're dealing with. Okay, so Kyverno will help you to do those 3 things. Validate means check to ensure that these YAML files conform to best practices or policies that you have specified within your own organization. Mutate could mean, if this policy does not conform, let's change it. Let's add some attributes which are required to make sure that the policy now conforms to what we would like it to be. And generate could be, let's generate some additional configurations or some additional, it could be labels or some addition that you want to have within the system to make it conform to your policies. Okay, and we're going to look at examples of each one of those very soon. Okay, so again, like I said before, Kyverno is Kubernetes native. So when you're working with it, you won't notice any difference between using Kyverno and the native Kubernetes objects. The reason for that is because, as you may know, Kubernetes can be extended, it's extensible. It has a concept of custom resources. So you can create your custom resources, which in programming, I can say this is like you writing your own classes and then using those classes within the your program to make your program even more easier to manage. So here you can write your custom resources, and then those custom resources form part of Kubernetes, so that anything you are doing within those custom resources looks like you're working with native Kubernetes. So Kyverno is Kubernetes native. So when you're working with it, you won't notice the difference, and that makes it very easy as well. All right. So it's also going to monitor your policies. And I like this aspect as well. The fact that you have the policies working doesn't mean that that is the end. Kyverno will continuously scan your policies, and if there's anything that needs to be done, it's also going to let you know. Okay, so the job doesn't stop just at the time you're trying to create. It will continue to monitor this on a continuous basis. All right, so I've talked about some of this before. All right, now this is the architecture. This is how the architecture looks like. When you deploy it, it's quite easy to deploy. And in the demo, you're going to see me deploy this. So once you deploy it, you're going to see this component, all of them running. Can be running in a couple of pods. And you can scale it. It will scale itself and make it, to make it performant depending on the usage that you require. Okay. So the bottom component here is actually the architecture for Kubernetes. For Kyverno. This one here, if you have been working with Kubernetes for some time, you would have seen this diagram here. And I've actually given a presentation on this before as well, when I talk about admission controllers. This diagram is here, but if you're not familiar with it, I also have the link here. It's taken from this Kubernetes link here. Okay, so you see that diagram is there. But this is a very important topic because it's a way to enhance the Kubernetes security measures. And so basically, if you want, you can go through this blog to understand more about that diagram. But let me try to summarize it for you. So you see that in most software or services, you have the authorization and authentication here, and then you don't have anything in between, all right? And then you have the system. So in other words, once you get authenticated and you get authorized, you can go straight and start using the system. That is how most applications work. In Kubernetes, you're not done yet. So if you are trying to send an API request, for example, you're trying to do kubectl, okay, kubectl create, which is like an API request. So that will come through here, the handler, the HTTP handler to, take the request in from the API. Then, of course, you still have to perform the authentication and the authorization. Okay, but after that, you still have these levels here to go through. Only when you have gone through this, only when the request has gone through this and everything is successful, will you have access to Kubernetes objects. Okay, so what this means here is that we have something called the admission controllers. And those admission controllers are the ones I showed you in that diagram earlier. So it's a way to have some additional requirement to validate those, to make sure that those validation went through before you let anything happen. Okay. So the example I used earlier, I can still use that here in terms of the image, but also related to image as well. You can say that if someone is trying to create a pod and the image is coming from a public repository, you do not want that to happen. Why? Because you want your environment to download images only from maybe your private registry. Okay, only the private registry is allowed on this cluster. And then if someone comes in with a pod that is trying to download the image from, let's say, Docker Hub, which is a public registry, now we can stop it at this point. We can stop it and say we don't want that to happen. Okay, so here, the two things here are the mutating. We have the mutating admission controller and the validating admission controllers. Mutating here means we're changing something. We're trying to make something work as we want it to be. And even though we have made a change here, we're still going to validate it here to make sure that that validation went through before you are actually allowed to use the resource in Kubernetes. Okay, so these are called admission controllers, and you can have you can generate additional additional admission controllers. And like I said, if you go through this article, it's going to talk more about all the admission controllers we have. It talks here about why do we need admission controllers, You see the first thing here is for security. And then we have things like governance, configuration management, which we're talking about. So you have all those things in place. And then you have some examples of a mutating webhook where you're trying to change some stuff. And then the validating, which you are just trying to validate some stuff. Okay. So we can see that all these features, even though before they were implemented in PSP with port security policy, so you can see it here, port security policies, this object is going to be deprecated. It will not. There's no desire to continue with it because people say that it's quite difficult to manage. But it's very important. You need things like the port security policies. And so again, just to emphasize, at some point you're going to need Kyverno or the equivalent. If you have a large Kubernetes cluster, you cannot avoid it because it's very important. Most especially again because they are deprecating this object. So the only replacement is going to be the policy management software, which is capable of implementing what you like it to do, as again across different clusters. Okay, so that is a diagram here that we have here. So basically, if you have here Kyverno is just saying that any request coming from the API regarding the mutation or validation will come straight into Kyverno. So Kyverno has a webhook that is going to take care of that, making sure that all the checks here are done, and we're going to see some examples there. And then also we have the monitor. All of them are here. We have the monitor. It creates and manages all the required configurations that we want to control. And then we have the policy controller here. This one is the one responsible for all the objects. When you create your policies, remember that your configuration files are creating objects. And so these policies here are going to be applied to the objects you want them to be applied to. Maybe you want them to be applied to a pod, you want them to be applied to a deployment or a replica set, or whatever it is you want them to be applied for. This is the one that is going to take care of that. And then the generate one here is the one that we're going to generate the configuration files. If you need to generate those configuration files, I say that there are three things we'll be talking about. We'll talk about the validate, the mutate, and then the generation, okay, to generate the YAML, the configuration files that you're looking for. So in a way, that is what the architecture looks like. And to deploy this is very simple. It's just a single YAML file provided for you. Once you run that YAML file, it's going to generate a bunch of all the resources required to make this to be integrated into your cluster. Okay, so those are the features there from the architecture. All right, so these are some of the features. I've already mentioned some of them. Policies, you write your policies as Kubernetes resources, all right? So you don't have any new language to learn. And this is actually in comparison to Gatekeeper. Gatekeeper has a programming language which you need to learn. I think it's called Rago or something like that, which you need to learn in addition to being able to use Gatekeeper. But here, there's no difference. You just use your YAML files. The way you create your Kubernetes objects is exactly the way you create these ones here. And then, again, we have validate, mutate, or generate any resource. Any resource coming in, be it a pod, deployment object, we have the capability to validate that the configuration is fine, or we can change the configuration, or we can generate new ones. Okay. And then it also has a concept of using labels. And those labels can have wildcards, which means you can use things like asterisks, question mark, on and on to match a bunch of objects, okay, to match a bunch of objects based on their labels, okay? And then you have the option to synchronize configurations across our namespaces, which is why we can use it across different clusters, okay? And then it has the option to block something you don't want it to be configured. If you have a policy in place and the policy, if you have a policy in place and that policy is violated based on how the object is configured, you can instruct Kyverno to stop, to prevent that object from being created. And we're going to see some examples of that as well. Okay, so it has all these examples there, which are pretty cool. Right. So again, we're talking about policies. Policies again means that we need to write those policies. Okay, like any Kubernetes object, you need to write your policies, and then once you write your policies, those policies will be applied across your objects. And to write those objects, those policies, which we're going to start looking at very soon, you say they look pretty much like any other Kubernetes manifest file. So if you're familiar with writing Kubernetes objects, it's the same thing. You can just follow the same way and write your policies. All right. So again, like most things in Kubernetes, the policy you write can either be scoped to a namespace or to the entire cluster. Okay. Usually, if you specify the namespace, then that policy will be applied only to the namespace. If you remove the policy, then it will be applied across the entire cluster. Okay, again, we're going to see some examples. Okay, so when you have a policy, you can specify rules. Okay, those are the rules that are going to be evaluated against your configuration, against your YAML files. If those rules are violated, then we can decide to do something about it, either to either to drop it or to allow it to just generate an audit. We can say generate an audit for us, or we can say, okay, let's stop this from happening. So we have all the rules. And this rule contains a match statement. Okay, we're going to see the match statement is going to say, let's select pods that has these labels, or let's select the deployment object that has these labels. Okay, then it has an action as well. And the action pretty much is what we've been talking about. You can either validate, or you can mutate, or you can generate it. All right. So we're going to see examples of those. But before we start looking into that, I want to show you that Kyverno is a CNCF project. It was recently, adopted into the Kubernetes, what I call the sandbox project. So if you're not familiar with Kubernetes, with CNCF, CNCF is the body that controls Kubernetes and the ecosystem. Anything microservices, anything cloud native, this is the body. In fact, our meetup is part of this. If you go to the community here and you search for under the meetups, you search there, you see our meetup on there because we're part of this body. Our meetup is a CNCF meetup. But basically, what I want to show you here is that CNCF has a lot of applications, open source applications that they've adopted into the family. Let me say that into the family here. And if I go here to the CNCF landscape, you've probably seen this before, but if you haven't, these are all the software that the CNCF has adopted and managing as part of its landscape. So if you come here to the CNCF landscape, you see a lot of software which they have adopted. My system is taking time to load, but in each category here, if you go in your system, you see just go to landscape.cncf.io, and then you see all the projects. Okay, mine is taking time to load. Well, basically, there are so many software here in the CNCF landscape. And the way they do it is that they will look at all the available open source projects. Okay, they will see those ones that are working in the cloud native landscape. Okay, they'll try to see what category they fit in, maybe within the database or orchestration or streaming or container runtime or whatever it is. Then they will try to compare or to see the features that the software provides, and then they will continue to interview people. They will look at the Git repositories. They will see how active it is. They will see what people are saying about the software and all sorts of things. So basically, they have a committee that look into those type of issues. And if they think that this software is something very useful for the community, then they will try to make it part of the CNCF landscape. But the project doesn't just come in and become part of the CNCF landscape. It has to go through some stages. And one of the stages is to be in a sandbox, which means they've selected this software they know that it has a lot of very good potential, and they want to continue the development, the enhancement of that software. So once they acquire that software, it becomes part of the CNCF. And usually that gives people a lot of confidence that this software has a lot of traction. And so currently, Kyverno is in that category. It has been adopted into the sandbox category. And so very soon, depending on how much work is continuing to be done on it, it could get promoted into a full-fledged CNCF project, which means at that point, it's gone through all the checks, all the security checks. It means that it's pretty much ready for production. Okay, so that is the stage Kyverno is, and that is the website for Kyverno. I clicked on it from there, and it came here. Okay, so I like the website a lot because I like the layout, especially if you just go here to get started. That get started will just take you to where you can actually really get started on a very meaningful level, because you can, once you have your cluster deployed, you deploy Kyverno, then you can run the examples and you see it in action. So you don't need a lot of learning curve, especially if you've been working with Kubernetes, which is the advantage I was saying earlier. It's part of the Kubernetes ecosystem. So it's very similar to how Kubernetes does things. All right. And also, if you come here to policies, under the policies, they have a lot of sample policies. And we're just going to look at a few of them. Okay. So here, when you come to the website, they have all these policies. Here you have 80 policies. You say 80 policies found. And you have all of them here. You can keep scrolling, which is a lot. 80 is a lot. So you can filter some of this. You can say, I want all the policies that validates. All right. The policies that validate, you see them here. And let's look at one. You say this one will say the deny privilege escalation. Okay, so this is something that PSP was doing before. So if you come here, it says privilege escalation, such as via set user ID or set group ID file mode should not be allowed. Okay, this policy ensures they allow privilege escalation field are either undefined or set to false. So they give you the example of the policy there, and we're going to look at how this how the policy reads, okay, in a moment. I already talked about them, but we'll come down to look at a typical policy file, what it looks like. What are the things to take care of, or to be to take note of, rather. So you can filter to all the validate, or you can go to generate. Not a lot of generate, only 3. Then you can come to mutate, and mutate here we have 16. So really you can see that the bulk of those 80 are from validate. So you can see here 64 policies for validating your files before they get created into your Kubernetes environment. You can also group them based on my best practices, different categories here, port security standard, restricted, on and on like that. So under the subject, if you're looking for things under network policy, or you're looking for things under pod, all the policies related to a pod, all the policies related to volume, all the policies related to labels, namespace, you can either keep clicking on them to see which ones you're interested in. So I think the website, I believe, to me, I think is quite well organized, because you can easily look for something, and also gives you a lot of examples. So you don't even need to try to write yours, except what they provide here is not sufficient, or except if within your organization you have your own policies defined. You don't even have to write yours. Just come here and reuse existing ones. Okay, so now let's try to create a simple policy, right? And as you can see here, we're going to do a validate. Okay, I already have some examples which I'm going to use, but you can look between here and let's search for levels. Let's see anyone that has level. Okay, a lot of them are here, so let's just see if we can restrict it to that. Let's deny privilege escalation. Let's go back. All right. In any case, I hope that gives you a good idea on how to get started. For me to show you one or two examples, I need a Kubernetes cluster to be up and running. And I have, I can use Katacoda for the demo. So I'm just going to refresh this and get a new cluster. Okay, so I'm going to have a cluster. And then on top of that, I'll deploy Kyverno. So here I'm just going to say launch. All right, so I have my Kubernetes cluster with just one node, kubectl get nodes, nodes -o wide. It's -o wide. I have just my Kubernetes cluster with one node, okay, which is sufficient for me to show you what I want to show you. So kubectl get pods -a. I have there my cluster, everything running as expected. Okay, so, but Kyverno is not here. So we don't have Kyverno deployed yet. So it's not going to be able to help us implement any policy. So let's go here and deploy our Kyverno. And you can see this line right when you go to getting started on the website. Go to getting started, you see that there. So I'm just going to run this. And that's it. Kyverno is deployed. You see it has deployment objects, deployment Kyverno created, service created, service config map, cluster role, on and on. A lot of objects are created, but all of them are good now. So if you do kubectl get deploy, kubectl get, let's see, namespace. It's not responding. Kubectl get namespace. So we have a namespace here called Kyverno. So kubectl get pods -n Kyverno. So we have only just one deployment object running, but we're good anyway. We're good to go. So now that we have it in place, the next thing is we can go ahead and create one or two policies. One of the policies we could play with is to make sure that we don't have any pod that doesn't have a particular label is not able to get created. So this one here, we will look at a typical policy, how it looks like, and then we can create it. So let me clear that, vim, let me call policy1.yaml, and let me paste that there. Okay, so we can see this is how a policy looks like. Like if you've been working with Kubernetes, you still have the API version. Here's kyverno.io version 1. We have the kind, it's a cluster policy. And then we have the metadata information, and then we have the spec. Okay, so we said validation, failure, action, enforce. So we're saying whenever this policy fails, what should happen? Let's enforce it, which means let's do what this policy is asking it to do. Enforce here is going to almost mean don't allow it to work. Don't allow it to get created if this policy does not conform to what we're specifying here. So what is the policy? You need to have a rule. So that's the rule. This is going to apply to a pod. Under the rule, we have a name for it. Then we have a match. Under the match, we're saying we want this to match a pod. Okay, you say match, then you say resources, kinds, and pod. If you want to put more resources, you can say deployment object. You can put a hyphen here, under enter, hyphen, deployment, on and on. All right. Then here we're going to do a validate. Remember, we have validate, we have mutate, we have generate. So here we're going to do a validate. If I wanted this to be a mutate, I just change that to mutate. Okay. And then this is what is going to get mashed. Okay. So the pattern here is that any pod that doesn't have a label should not be allowed to get created. That's what this is saying. If you create a pod and it doesn't have any label, do not allow it. Well, actually, let me change that a little bit. If you don't have a pod that has this label, app.kubernetes.io/name, and you give it a name here. If it doesn't have this label, starting with this, and then something in here, don't let it happen. Don't let it be created. So you can see here, we're using a wide card, which means we don't care what name you put here. Whatever name you put is fine. So long as the label starts with app.kubernetes.io/name, and then whatever name you put here, it doesn't matter. Okay, and then if this rule doesn't get created, if it doesn't meet the requirement, generate this error. Just say the label is required so that the user knows what is going on. So this is how a typical policy looks like. Now we have everything we needed. We have the usual for any Kubernetes file. Then we have the what to do if this rule is not met. Then we have the rule to know what it has to be applied to based on the match we have here. Then we now specify what should happen. Is it a validate, is it a mutate, or is it a generate? And then we say, okay, now this is what we're going to interested in. This is the check we're going to perform. If that check doesn't happen, if that check doesn't is not met, give that error message and enforce it, which means don't let this guy get created. So that is the policy we have there. For this one, again, like I said, it requires that a pod has that label in there. If it doesn't, it's not going to let you. It's not going to let a pod be created. Okay. So let me create it just like Kubernetes. It's just kubectl create -f. Okay. So there's an error there. So let me open it again and see where the error is. API version. And see the error there. Said line 2. Line 2. Okay, that's API version. That's a kind. I don't know what is not liking there, but I had that earlier, so I will go and create it again. I'm not able to spot anything in there, but YAML files and YAML and JSON files are very, very picky. Any tiny little thing is not going to work. Okay, so let me just generate a new one. That is actually directly from the Kyverno page. So let me go back and then generate it properly. So if you go to the getting started, that was the example from the getting started. So it's not going to be difficult to make work. So let's go to the home page and let's go to getting started. And that is this one here. So let's see. Let's generate that again on our cluster. All right, so that has been created. So kubectl get cluster policy. Okay, so require labels, that has been created. So okay, so now that it's been created, let's test it. How do we test? Remember, this rule said anytime you create a pod, it must have a label like this. Okay, so let's create one without that label. Let's say kubectl create deployment. Let's call it Nginx. And let's have the image Nginx. Very common example of creating a pod. All right, so if you can see, it's giving errors. It said error from server, admission webhook, validation Kyverno SVC deny request. Resource deployment was blocked due to the following policies. Require labels. Okay, you have the require labels there, and it said that label is required. So there's a particular label which has to be like this. It's required, but I don't have it. Because when I created this pod, I did not give it any label, right? So because I didn't give it a label, it's not going to let me do that. So let's create another one, and let's make sure that we have the labels properly in place. And for this one here, I have it available here with a label just to make it easier. So we'll come back here and let's paste this one. Now, if I say kubectl get pods, there should be no pod created because that pod wasn't allowed to get created because it didn't conform to the policy. But now I'm giving it a label. I'm saying app.kubernetes.io.name equals nginx. So because I'm giving it a label, starting with what is expected here, okay, so this one should work. All right, so say the pod has been created. And now if I say kubectl get pods, I have that the pod is still getting created. All right, it's now running. And if I say -- show labels, you see the label is there. app.kubernetes.io.name equals that. Now, if I try to create another one and I make a mistake in that label, I'm going to give it a new name. It's now moving to the end, to the beginning of the line. Command A, oops, Control A. Okay, it's now getting to the end of the line, but let's say kubectl, let's say kubectl run nginx -- image equals nginx -- labels app dot k8s.io/name equals meetup. That one too is not going to allow it because it's expecting to have exactly what I put in there. Here I put K8s, which is not Kubernetes. So in other words, yeah, any mistake here, this is not going to work. So that's an example of a validating webhook. We're trying to validate that that any pod you create has this label. And this can be a useful example because maybe you have developers that you want their pods to have certain labels, and maybe some of them are careless. They can't care to put the labels in place. And when you deploy those pods to your cluster, then later on searching for them will be difficult because they don't have the right labels. And so the administrator can decide to enforce this. So say, okay, if you don't have these labels, we're not going to let you create this cluster. And again, don't forget, this can be managed centrally. The administrators, the Kubernetes administrators, can manage this across the entire enterprise. It doesn't matter how large the Kubernetes deployment is. You can still enforce this. Okay, so that's one example. Let me delete it. I always try to delete policies when you don't need them, but otherwise you're trying to do something else and then they are breaking. So let's do kubectl delete -f policy1.yaml. Okay, so let's delete that kubectl get policy name we gave it earlier. Okay, all right, so now let's do kubectl delete cluster policy, and let's say require labels. All right, so that's been deleted now. So any pod will get created now, no problem. Even the last one that was giving me error, that should get created, except it's saying that the name exists. So let me change the name to nginx1. So everything should now getting created because there's no more policy restricting anything. All right, so that's a good example of a validating webhook. Let's look at another one that I have in here. We can look at an example of a mutating one, something that is meant to change what you have in there. And some of these examples, again, they're directly from the the Kyverno website. So this one is from this link here. So let me click on this and paste it there. So if you want to practice this later on, it's quite straightforward since they provide all the examples. So remember that mutating means change. Okay, we're changing something. So this one here says add labels. Labels are used as an important source of metadata description objects in various ways, or triggering another functionality. Labels are also a very basic concept and should be used throughout Kubernetes. This policy performs a simple mutation which adds a label for equals bar to anytime you create a pod, a service, or config maps or secrets. This will automatically add a label to it. Okay, so let's try that as well. Let's click on that, and then let's copy that example here. Let's go to our cluster. Let's vim mutate.yaml, and let me just paste it here. All right, come out of this, and then I do kubectl create -f, and now it's created. So anytime I create a pod now, it's going to have those levels. So let's do kubectl get pods --show labels -show labels. These ones, they are there. There's nothing like for here. There's nothing like bar here. But if I create a new one now, hopefully it should insert that. Yep, so let me just create this one, make it simple. Let's change this one just in case that one's still there. Kubectl run. Okay, so now we created a deployment and a pod. So if you say kubectl get pods, we have the pod we just created, which is 11 seconds because it's Nginx 2. Okay, now let's see the labels. -show labels. Now we see this one has for equals bar. So you see the policies in place. Anytime you create a pod or a deployment now and you see the labels, this will be added. So that's an example of a mutating. We're changing something within our pod. And you see how this can be handy. You can do this across anything, any pod you're creating. You can say any pod coming from test environment. Always we have that label called test. Anything coming from prod environment should have the label called environment equals prod or tier equals prod, things like that. So that's an example of a mutating mutating policy. Then let's have an example of a generate. Okay, something that will actually generate a policy for us. Okay, so this one here also from there. So this example here, I like it as Kubernetes administrator. I really like this one. This one has to deal with when you create your namespaces, you can enforce quota to be implemented. So if you create a namespace and you don't give it any quota, then that quota can end up using all the resources in your system. But if you give it a quota, then it's going to get limited. Once it gets to a certain, once you exhaust the quota, then you can no longer use it. So let's see how this works. This one is going to apply to any namespace that you create going forward. Any namespace you create. Okay, again, let me delete the previous one so we don't mess things up. So kubectl delete and delete -f mutate. Okay, so we deleted the mutate one now. And if I want, I can delete kubectl get deploy. Okay, kubectl get pods. Okay, now kubectl delete pod nginx 1 and nginx 2 or 1. Okay, let's delete all of them. So now once that is done, we have a clean system like we had it before, and then we'll create this. So kubectl get ports, nothing in there. Kubectl get namespace. Okay, so let's say kubectl. Okay, all right, kubectl create namespace meetup. Let's do that meetup, and let's do kubectl describe meetup, describe namespace meetup. Okay, so we'll check, we'll compare against this one, but you can see this one has no resource quota, no limit range resource. Okay, because we haven't implemented policy, so nothing is implemented here. So now let's create a policy. Let me call this one generate.yaml. And in here, I can paste generate. Say this one is a long policy, but it just have few rules. There's this rule one here, which has a hyphen. The name here is generate resource quota. Okay. Then if you come down here to the second rule, this is generate limit range. So it's actually doing two major things for this this rule here. And then if you look at it here, you see the same thing, the API version, the kind, the metadata. Then you have more information here, like the annotations, things that you can easily read and it will make sense to you. And then after that, the policy is there. So let's save it. And hopefully this one will create kubectl create -f generate. Okay, again, it's having some error on that line 2. I don't know what is it with that line 2. When I copied API version, API version, the same line 2, and let's see what line 2 is here. API version, kind, set number. Yeah, that is a kind here, but I don't know what, that's a cluster policy. Okay. Cluster policy. So let's go and create this one again. Kubectl create -f generate. Create -f. All right, let's get it from here. I did not put the URL for this one here. I didn't put the URL for the policy here, but I got it from the policy here. So let's quickly search for that. Is a generate, and it's for the namespace. It's a generate, and it's for namespace. Do you have namespace here? Okay, it's this one here, add quarter, I believe. Let's go here. All right, cool. Yeah, it's this one here. So let's copy that. It's the same thing I did earlier, but I don't know what the problem is. All right, so let's create one here. Vim mutate. Let's remove this one first. All right, so Vim mutate the YAML. Okay, now kubectl create -f. All right, so now it's happy. So this one here, kubectl get, let's give it a few minutes to warm up, because this one is quite complex. So it should take a little bit of time to properly get created and ready. In the same time, if you say kubectl get namespace, describe namespace, describe namespace meetup. See, this still doesn't have anything there. Now let's test this. Kubectl create namespace and let me call it cloud native. Create namespace cloud native. So cloud native has been created. So let's describe it like we just did. Cloud native. Yeah, so you see this one now has resource quota and it has resource limit. Again, if I do the previous one, meetup, nothing. Because at the time I created this, there was no rule to generate, automatically generate the resource quota. But now any namespace I create is going to have that in place, which is, like I said, is quite handy for the administrator because we want to make sure that your namespaces are all properly configured so that they don't exceed their quota. So let's just create another one just to show you, and then we'll round up. So let's do this one, Cloud Expert. Cloud Expert. All right, so let's describe it again. Cloud Expert. Expert. Again, you see all of them have everything included. So this is, I really like this one. But again, like I said, you can easily play with this. All the rules are here. Just come here under policies and then start looking for them. If you want to get started, just go to the home page, and right there on the first page shows you how to deploy Kyverno and then how to have something running. And I really like this because all the examples are here for you to follow through. And you can easily search for them to tell you what you're doing. All right, so pretty much that is what I had in mind to show you guys today. Kyverno is very important. In case you don't realize that by now, if you're running Kubernetes in production, I would say most likely you're going to need it. If not now, pretty soon. And also, it's getting more and more popular. A lot of people are now beginning to talk about it. So I think it's definitely a project to watch out for, and maybe to start implementing too. If you're not already using it, maybe you're just being informed about it. Maybe you knew about it. Maybe you're already working with it. Whatever your situation is, I think it's a very useful project that you're going to need, especially when it comes to security. And we've been talking about security in the past couple of meetups, so I thought that would be a good, this would be a good time to present it. All right. So from my side, I'm done. But I would like you guys to, again, understand we always need speakers, okay? We always need speakers. If you have something to share, please feel free to let me know, and I'll schedule you. If it's a personal project, that is fine. If it's a project related to your organization, then we also need sponsors, because every meetup needs sponsors to keep it running. And so we do require that they sponsor the meetup in one way or the other. All right. So far, I haven't seen any question here. So it looks like there's no question. If you have any question, feel free to write it now. We can discuss it. If you have anything to add, feel free to add. Otherwise, pretty much like I said, I'm done, and I will be signing off. And so the next meetup is going to be next month. We're going to have Eric coming to talk, and also if we have another speaker, then we might have two speakers. Otherwise, it might be maybe just Eric, or maybe I will present as well. I'm not sure at the moment. All right. Again, thanks for attending. Thanks for watching. Thanks for supporting the meetup. And I hope to see you next month.